Hello everyone. Welcome back to our YouTube channel. We hope you're finding everything here simple and easy to understand. We kindly ask you to subscribe, like, and hit the notification bell to receive more simplified tutorials from Professor Photon. We're going into the details of the Wankel engine today. It is sometimes called the rotary engine. In this tutorial, we're going to discover this about Wankel engine. 1. Definition of Wankel engine. 2. Its parts and how they work. 3. Construction of Wankel engine. 4. Working principle of Wankel engine. 5. Then we know why Wankel engine is uncommon. 6 advantages and disadvantages of Wankel engine. 7. Applications of Wankel engine. Then we end by differences between Wankel engine and reciprocating engine. Let's start with a simple question. What is Wankel rotary engine? Wankel engine is defined as a rotary internal combustion engine in which a curved, triangular or eccentrically pivoted piston rotates in an elliptical chamber, creating 3 combustion spaces that differ in volume. Or in simple words, it is an internal combustion engine that uses an eccentric rotary design to convert pressure into rotational motion. The Wankel engine works on the ordinary Otto cycle. Parts of Wankel rotary engine and their functions. The following are the parts of a Wankel rotary engine. 1. Intake port 2, exhaust port 3, crown gear 4, rotor 5, combustion chamber 6, housing 7, eccentric shaft 8, apex seal 9, spark plug. Functions of the parts of Wankel engine. 1. Housing. The engine's main casing, typically a rounded or oval shape, contains and encloses all the other components. 2. Rotor. This is the heart of the Wankel engine. It's a triangular or trapezoidal-shaped component that rotates within the housing. The rotor has 3 key parts. Apex seals. These are located at the tips of the rotor and form a seal against the housing. They prevent air and fuel leakage as the rotor moves. Side seals. Positioned on the sides of the rotor, side seals also help maintain the combustion chamber's seal as the rotor turns. Cooling channels. Some rotors have cooling channels to manage heat generated during operation. 3. Eccentric shaft. The rotor is mounted on this centrally located shaft and it rotates within the housing. The eccentric shape of the shaft is what causes the rotor to move in an orbiting motion inside the housing. 4. Spark plug. Like in traditional internal combustion engines, the spark plug ignites the air-fuel mixture inside the combustion chamber. 5. Intake and exhaust ports. These are openings in the engine housing that allow the entry of air-fuel mixture and the exit of exhaust gases, respectively, as the rotor turns. 6. Combustion chamber, the space created by the rotor's movement where the air-fuel mixture is compressed and ignited to produce power. 7. Housing seals. These are gaskets or seals that prevent leakage of air, fuel, or exhaust gases from the engine. Construction of Wankel engine. This image and animation shows a simplified construction of the Wankel rotary engine. It consists of a 3-lobe rotor, a rotor of triangular shape with curved sides that rotates eccentrically in an oval chamber. The rotor is mounted on the crankshaft through external and internal gears. The rotor lobes are sealed tightly against the sides of the oval chamber. The combustion of rotor and chamber shapes ensures that they remain in contact with each other throughout the rotation. The rotor has an oval-shaped depression on its 3 sides between the lobes. What is the working principle of Wankel engine? The Wankel engine is an innovative internal combustion engine with triangular rotary pistons that convert combustion pressure into kinetic energy. Unlike traditional engines, it features circular piston motion without a separate crankshaft, resulting in direct energy conversion. It's valveless, making it lighter and more compact, reducing vibrations for a smooth operation. The engine goes through 4 strokes: intake, compression, ignition, and discharge or exhaust stroke, similar to a 4-stroke Otto piston engine. Here is the summary of how the 4 strokes happen in Wankel engine. The Wankel engine, also known as a rotary engine, operates on a unique design with 4 key strokes. Intake. During the first stroke, the rotor moves away from the engine housing, creating a partial vacuum that draws in the air-fuel mixture through the intake port. Compression. In the second stroke, the rotor begins to move back toward the engine housing, compressing the air-fuel mixture within a sealed chamber. Power. The power stroke is the third phase, where a spark plug ignites the compressed mixture, causing it to expand and push the rotor, generating power directly without the need for reciprocating pistons. Exhaust. Finally, in the exhaust stroke, the rotor continues to move, expelling the exhaust gases from the chamber as it completes a full revolution. Why is the Wankel engine so uncommon? Here are some of reasons why Wankel engine is uncommon. 1. Low thermal efficiency. The Wankel engine's combustion chamber is long and irregular in shape. As a result, its thermal efficiency is lower than that of reciprocating engines. Unburned fuel frequently escapes the tailpipe as a result of this. 2. Burn oil. These engines burn oil because of their design. This engine's intake manifold has squirters and an injector that pumps oil directly into the burner. Because of this, the exhaust emits more harmful substances. The environment dislikes harmful substances. 3. Rotor sealing challenges. The rotor sealing of a rotary engine can be challenging when the temperature around the rotor varies greatly. This issue raises the engine's emission rate. Remember that the suction and burning processes happen simultaneously, but in different parts of the engine housing. This indicates the temperature at the top of the engine housing is lower than at the bottom. 4. High emission rate. Wankel rotary engines are not well known due to their high emission rate. Engines that fail to meet current fuel economy or emission standards are caused by sealing difficulties, inherent oil combustion, and inefficient combustion. 5. Poor fuel economy. Compared to reciprocating engines, Wankel engines consume more fuel. High fuel consumption results in higher fuel prices. Advantages of Wankel engine. A Wankel engine has many advantages, but here are some of them. 1. Compact design. Wankel engines have a compact and lightweight design compared to traditional piston engines, making them suitable for various applications, including automobiles and small aircraft. 2. Smooth operation. They provide smooth and vibration-free operation due to their rotary motion, leading to reduced noise and improved comfort. 3. Fewer moving parts. They have fewer moving parts compared to piston engines, which can lead to reduced maintenance and increased reliability. 4. Simplified cooling. Their design often simplifies the cooling system, reducing the risk of overheating. Disadvantages. The Wankel engine, while having some advantages such as compact size and smooth operation, also has several disadvantages. 1. Lower fuel efficiency. Wankel engines typically have lower fuel efficiency compared to traditional piston engines, especially at high speeds and under heavy loads. This is due to their design and combustion characteristics. 2. High emissions. They tend to produce higher emissions, particularly in terms of unburned hydrocarbons and nitrogen oxides, which can be challenging to meet stringent environmental regulations. 3. Apex seal wear. The apex seals in a Wankel engine, which seal the combustion chamber, are prone to wear and can require frequent replacement, leading to maintenance issues. 4. Oil consumption. These engines tend to consume oil more than piston engines, which can lead to increased operating costs. 5. Limited torque at low RPM. Wankel engines typically have less low-end torque, which can result in slower acceleration from a standstill. These are some of the disadvantages that have contributed to the limited use of Wankel engines in mainstream automotive applications, although they have found niches in some sports cars and other specialized vehicles. Wankel engine applications. The Wankel engine has several applications, although it's less common than traditional piston engines. Some of its applications include 1. Automotive. Mazda is one of the most well-known manufacturers to use Wankel engines in their vehicles. These engines are known for their compact size and smooth operation, which can be advantageous in sports cars and certain specialty vehicles. 2. Aircraft. Wankel engines have been used in small aircraft, particularly in experimental and ultralight planes. They offer a high power-to-weight ratio, which can be valuable in aviation. 3. Motorcycles. Some motorcycle manufacturers have experimented with Wankel engines, primarily for their lightweight and high-revving characteristics. 4. Power generators. Wankel engines have been used in stationary power generators and backup generators due to their compact design and ability to run on various fuels. 5. Watercraft. Some personal watercraft, such as jet skis, have used Wankel engines because of their compact size and high power output. Comparison of Wankel engine and piston engine. 1. Operating aspect. The Wankel engine uses rotor for operation, while piston engine uses pistons. 2. Weight and size aspect. The Wankel engine is lighter and compact, while piston engine is heavier and bulky. 3. Emission aspect. The Wankel engine has higher emissions compared to piston engine with less emissions. 4. Smoothness. The Wankel engine is more smooth in operation due to its continuous operation, while piston engine is less smooth due to its piston movement. Those are some of comparsions of the two engines. Thanks for watching this video. Kindly don't forget to click the subscribe button down there. When you subscribe, Professor Photon will get to know that you enjoy what he lectures, and he will give in much time to deliver simplified engineering content. I hope you don't forget all you have learnt. Bravo!